Hello everyone, in this video we will find the Fourier series with 5 terms of the following square wave. Note that this question is very much similar to the previous question finding square wave of a certain function fx. However, you can see that the square wave now shifts to this part of the graph, okay, and is given as fx equal to 1 if x is greater than negative pi over 2, so right here is negative pi over 2, and less than pi over 2, and then fx will be equal to negative 1, this part right here, if x is equal to pi over 2 and less than 3 pi over 2. So this part is 3 pi over 2. Okay, so what we need to do in this case is, first of all, we still do the analysis, and this waveform is even and it has halfway symmetry. Okay, if it's even, then what should we do? So now, again, the same thing, we go back to our formula sheet on the workbook, and on this page it said that if the waveform is even, then I only have the cosine term. I don't have the sine term at all. I may have a constant term, okay? And if this wave is halfway symmetry, then I only have the odd harmonics. So in this case, I should have the odd harmonics of cos. So odd harmonics of cos, I should have that, I should have that, I should have that, and so on. Okay, and they asked me to prove that A naught is equal to 0, so we are going to do that. To this waveform, we have halfway symmetry, even, only have cosine term, and the odd harmonic of the cosine term. Alright, so, and this one, I should say that it is A1, right? A1, A3, A5, A7, A9. Okay, and this one should be none. As analyzed here, the function is even and it has halfway symmetry, so it's even, so no b term. So we are going to use integration and apply the formulas to find the coefficient an in order to write our 5 terms of this Fourier series, so that get started with that. Alright, okay. So but first of all, the question asked me to prove that A naught is equal to 0. So let's work with that first. Okay, so prove A naught equal to 0. Okay, so what I would like to do is I would like everyone to take a look at our formula sheet again. And on this formula sheet, on page number 13, you see that A naught is given as this formulas. Okay, so this is my A naught. So I will write that down. So A naught is equal to 1 over pi, evaluate at the fx dx. Okay, and in this case, fx dx is given as this form. So let's write that down. Okay, so to write it down as a reminder for ourselves what we are working with. So fx equal to 1 if we have pi over 2 less than or equal to x less than pi over 2 equal to minus 1, if it's pi over 2 less than or equal to x less than 3 pi over 2. Okay, so I need to write this down. I need to put negative pi over 2, 2 pi over 2. Okay, so this is negative pi to pi over 2. And I add that with 1 over pi, again, the function fx in this case, and dx, but I need to write from pi over 2 to 3 pi over 2. So a naught will be equal to, okay, 1 over pi. I factor out the 1 over pi. What I have left inside the bracket, I should have these as integral of negative pi over 2 to pi over 2 of the function 1 times dx, okay, plus integral from pi over 2 to 3 pi over 2, and again this part I will have negative 1 times dx. Okay, close the bracket. So what is integral of 1 dx? Okay, integral of 1 dx should be equal to x, but I must evaluate x as negative pi over 2 to pi over 2. And in this part, what you do is also equal to 1, but you pull out the negative. Okay, so then I should have, excuse me, is pi over 2 and then 3 pi over 2 in this case, close the bracket, apply fundamental theorem. Don't forget that we need to have f of pi over 2 subtract f of negative pi over 2. Okay, in this case, I should have f of 3 pi over 2. I subtract that with f of pi over 2. So a naught will be equal to 1 over pi. Okay, so x is pi over 2, so I write pi over 2. Subtract that with negative pi over 2. Subtract of x, because I subtract these two terms, so I should write it in the bracket. Okay, so let's use another color so that you recognize that I apply the fundamental theorem in this case. So I will have 3 pi over 2 subtract the pi over 2. Okay, so I still have the big bracket outside. So now you can see that I can write this as, okay, I can put a bracket like this. So you see that I apply this part to this x, and right there, that's what we have. Okay, so now a naught will be equal to 1 over pi. I should have pi over 2 plus pi over 2. Okay, so this part I should have subtract 3 pi over 2 plus pi over 2. Okay, so let's see what we have. Okay, so if I add these three terms, okay, then I should have it as 3 pi over 2. Okay, you have the same common denominator, 2, 2, 2. Pi add pi, you have 3 pi. 3 pi over 2 subtract 3 pi over 2. In this case, is equal to 0. And 0 times 1 over pi is equal to 0. So it's proven that a naught is equal to 0. Alright, okay, so it's proven. So the next step is to find the Fourier series of this square wave with its 5 terms. Okay, so to do this, the first thing we have to do is we have to write down the equation to find our an. Okay, so go back to our formula sheet. So we need to write this down. Okay, so we need to write that down. an is equal to, okay, so 1 over pi. So in this case, I should have fx cos of n times x dx. Okay, so let's check the upper limit and the lower limit. So in this case, it will be negative pi to pi, but that is the general formulas. Okay, so negative pi to pi. So it is a general formulas. So we just use this only to remind ourselves, but we need to apply the correct intervals for this an. Okay, so this an will be equal to 1 over pi, and what I have is I should have negative pi over 2 to pi over 2. The function is equal to 1 multiplied by cos of n times x dx. I should also add that with 1 over pi, the integral from pi over 2 to 3 pi over 2, and at this interval the function is equal to minus 1, and again times cos of n times x dx. Alright, okay, so let's simplify. The functions right here. At the same time, I will factor out the 1 over pi. Okay, factor out 1 over pi. Inside the bracket, I should have negative pi over 2 to pi over 2. This one is cos of n times x dx. Okay, so I already factor out 1 over pi, and I will pull the negative to the front. So I should have pi over 2 here to 3 pi over 2, and still cos of n times x as the argument and dx, and close the bracket. Alright, okay. At this point, we have to integrate this cos of nx. Okay, unspecified with the n. Again, we are going to use our formula sheet to find a shortcut for that. Okay, so on this formula sheet, I believe it's on page number 11. So go to our page number 11. I would like everyone to take a look at this sheet and try to find the integral of cos of nx dx. Okay, so I found it right here. Formula number 9, integral of cos of nx dx will be sine of nx divided by n plus c, but we are working with definite integral, and we have to apply fundamental theorems in this case. Okay, so an equal to 1 over pi. I will write this as sine of n times x divided by n, evaluate from negative pi over 2 to pi over 2, and I subtract that with sine of n times x over n, again evaluate at pi over 2 to the 3 pi over 2, and close the brackets. Everything still have to multiply by 1 over pi. Okay, so apply fundamental theorem. Okay, apply fundamental theorem. So let's remind ourselves, I should have f of pi over 2 subtract f of negative pi over 2 in this case. Here I should have f of 3 pi over 2 subtract f of pi over 2. Okay, so then my an will be equal to 1 over pi, and I should have, where the x is, I will substitute with pi over 2. Okay, so sine of pi over 2 n. Okay, so why don't we pull out the 1 over n at the same time. Okay, so I am going to make a reminder here. We also factor out 1 over n. Okay, so right here I will write it as n times pi. Okay, so that will give me sine of pi over 2 times n in the bracket, subtract sine of the next term would be this, so sine of negative pi over 2n. Okay, so now I will subtract sine of 3 pi over 2 times n, and because of the negative right here with a negative, my next term should be a plus, so I should have sine of pi over 2n, close the bracket. Alright, so 1 over n times pi. Okay, so then let's write it like this. Okay, so this term I leave it alone, but I know that I can do something with this term right here. Okay, with this term, what I'm going to ask you to do is I have given you a hint above. Okay, so let's go back to this. I'm giving everyone a hint on this question. Sine of pi over 2n is exactly equal to negative sine of negative pi over 2n. So let's use that. Okay, so here I was given a hint as negative sine of negative pi over 2n will be equal to the positive sine of pi over 2n. Okay, the hint is given, so I will apply to this. So when I apply to this, I should have plus sine of pi over 2n. Right here, I will move this sine over 2n, I will write beside this one. Okay, pi over 2n, and I subtract that with sine of 3 pi over 2n and close the brackets. Okay, so what do we have next? Alright, okay, so an will be equal to 1 over n times pi. Now you see that you can add these 3 terms, and I can write it as 3 times sine of pi over 2 n. Okay, and subtract sine of 3 pi over 2n as the argument, and note that this and this are totally different from each other. Alright, okay, so can we simplify any further? No, we cannot. So therefore, these here, this entire thing is our general term for an. Okay, so we found that already, general term for an. And my next step is to figure out A1, A3, A5, A7, and A9. Okay, so what we do is now I will write A1 is equal to, so where the n is, you substitute in the 1. So 1 over 1 times pi, 3 times sine of pi over 2, subtract sine of 3 pi over 2. Okay, so we can use calculator to figure this out. So A1 will be equal to 1 over pi. So this will be 3 times 1, sine of pi over 2, which is 90 degrees, is equal to 1. And this should be equal to minus 1. Close the bracket. So I should have 1 over pi times 3 plus 1. So in this case, I should have 4 over pi. Okay, so 4 over pi is my A1. So now let's start with my A2. No, it's not A2. We don't have the even harmonic here, right? So we should have the odd harmonic only. So it's A3 will be equal to 3 times 1 over 3 times pi. In here I should have 3 sine of 3 times pi over 2 subtract sine of 9 pi over 2. Okay, so you see, so let's show everyone this part. Why I got 3 pi over 2? Because here is the n. Okay, here's n. Okay, then n is equal to 3. Therefore, I take 3 times pi over 2. I got 3 pi over 2. Here is n. N multiplied by 3. Therefore, I have 3 times 3. I got 9. Alright, okay, so that keep that in mind. So in this case, I'm going to ask everyone to use calculator. Okay, you can use calculator and put the in radian mode, and then you can calculate these values. So A3 will be 1 over 3 times pi. This should give me minus 1, and this value should give me 1. Okay, so I will have 1 over 3 times pi. In the bracket, I should have negative 3 minus 1, so I should have negative 4 over 3 pi. Okay, so let's circle our term. There I have 4 over pi. I have negative 4 over 3 pi. Okay, so let's start with A5. A5 I should have 1 over 5 times pi multiplied by 3 sine of 5 pi over 2 subtract sine. 3 times 5 would be 15 pi over 2. Okay, again I ask everyone to use your calculator. Okay, use your calculator. We should have 1 over 5 pi. Inside the bracket, I should have 1. I should have minus 1. So in this case, I should get back to 1 over 5 pi. Inside the bracket, I should have 3 plus 1. So I should have 4 over 5 pi. Okay. Alright. So if you do the similar calculation, okay, then I would like everyone to see that A7 will be equal to negative 4 over 7 pi, and A9 will be back to positive, which is 4 over 9 pi. Okay, so now we need to write it as a Fourier series. So fx. Okay, so let's get back to our formula sheet. On this formula sheet, you see that fx is this, okay, the summation of this in terms of the cos term and the sine term, but we don't have A0 in this case. We don't have this in this case. We only have cos, but we only have the odd harmonic. Alright, so let's write it down. So our fx will be equal to 4 over pi, which is my A1, times cos of x, right? So this is my A1. And then I add that with my A3. A3, I found it to be negative 4 over 3 pi. So negative 4 over 3 pi, and this I will multiply by cos of 3x. Alright, and this is my A3. And what you have is you have A5 next. So you find A5 to be 4 over 5 pi cos of 5x. Okay, and this is my A5. And I will add that with negative 4 over 7 pi, and I need to multiply that with cos of 7x. Okay, so in this case, this is my A7, and I add that with my A9, right? So what is my A9? A9 will be adding 4 over 9 pi cos of 9x. Okay, so let's factor out the 4 over pi. Okay, I will factor out 4 over pi. What I have left inside the bracket would be cos of x, subtract cos of 3x over 3, add that with cos of 5x over 5, subtract cos of 7x over 7, add that with cos of 9x over 9. Alright, so this is the Fourier series with 5 terms for the sine wave that given to us, and that sine wave is that a sine wave? It actually consists of all the cosine wave. Adding all of them together will give me that square wave. And in this Fourier series, I have 5 terms as indicated. Okay, so they asked me to find 5 terms of the Fourier series. Okay, 5 terms of this Fourier series. Okay, for the square wave, but the square wave is the sum of all this cos, and the sum of this cos, and I only deal with harmonics, the odd harmonics in this case. Alright, so in the end, this is the final answer for the Fourier series. Don't forget to include the fx. Alright, thank you everyone.